Last time we spoke over about a year ago, you were talking about the fact that we were only just starting to scratch the surface with regards to embracing the capabilities of technologies into our cars. A year on, how are you seeing that that's changed, and how are we progressing, and actually are we any closer to autonomous vehicles?
Yeah, so I think the thirst there to get to level 5 self-driving cars is still very much there in the industry. Technology is making huge bounds, and we're seeing our customers coming up with more and more complex systems. What we are seeing is a bit of a shift and a refocus on the goals a little bit, and you're seeing quite a lot of that in the UK, where people are working out that going for self-driving passenger cars is maybe not the first place to start, and we're seeing a focus on kind of delivery services, mass transport, and they're kind of the initial targets for this autonomous driving. And the UK government have actually starting to fund what they're calling deployment projects. So really putting this technology from kind of proof of concept actually out into the real world, where they're able to kind of mingle with people, other vehicles, and things like that. So the whole technology is taking a massive step forward from a lot of proof of concepts where we were talking last year to now the big thing is kind of deployment in the real world.
So what are the key investment areas for you in the automotive space? We've spoken before about in-life and the need to test and monitor silicon ICs for their entire lifetime rather than just making sure they work once. How's this changing your approach and the technology that you're providing?
So our key investment areas across the whole automotive supply chain, not just focused on autonomous vehicles, we're really, for our customers, focused on 4 key areas. The first one being quality. So for our customers to get products and components out the door with 0 defects is absolutely critical. So from a component testing perspective, we have a whole range of what we call advanced fault models, where our test technology can test for kind of all of the very specific defects that you see in silicon ICs. This technology, we started developing this probably just over 10 years ago, but it's continuing to advance. And as we see advances in the technology, we're seeing more and more kind of different defect types that we're having to build fault models for. So that's really important. And it's not just about what we call the time zero, where the device is manufactured. There's also the potential there that there's defects kind of lurking in the device that are not prevalent yet, but they're kind of what we call latent defects. So you put the device in a system, you run it for a few hours, and then all of a sudden they appear. So our next step is really looking at different fault models that we can introduce that will kind of flush those latent defects out of the system when you test at manufacturing. So that's quality. The next one is really safety, and for that we have all of our in-system test technology, which is able to continuously test your device throughout its whole life cycle. And the important thing there is that obviously when you're building these automotive systems, you have to meet certain standards. All of our customers are really focused on the ISO 26262 safety standard. So our in-system test technologies will help them achieve that certification for their products. And then looking a little bit out into the future, we have reliability. So safety is very much focused on detecting defects that have occurred, which is great. You make sure that your vehicle's safe. However, safe is not the same as convenient. Having your vehicle pull up on the side of the road because something's gone wrong is not the greatest experience. So we're looking at reliability and being able to detect when defects are likely to happen, so we can preemptively go in and fix them and flag that your car's maybe going to have a fault in the next so many weeks, so the manufacturers can do preemptive maintenance. And then, of course, security, which is the newest of all the topics. We've got the ISO 21434 standard that came around in 2021, and we've got a whole range of customers trying to get their head around what that really means to them. The standard's very clear in the process that you have to take to firstly identify where potential attacks can take place and what impact that will have on the device. But then how you detect those and mitigate those is a completely different topic. And that's where our embedded analytics technology that we talked about last time really comes into play.
And are there any particular advances in the semiconductor technology that make these areas more challenging? And how are you going to be able to meet the demands of the technologies required to enable self-driving cars?
So in terms of what we're seeing for the future, and this is seen across the whole of Siemens EDA, not just the Tessent test portfolio, is we see three big advancements in semiconductor technology. So first of all, you've got scaling around technology nodes. So as the technology node itself gets smaller, we see more and more different defect types. That makes the devices harder to test, so we need more different fault models. Then you've got design complexity, especially when you're heading towards the autonomous driving. These systems are getting vastly complex. And even things like the in-system test technology, being able to test a device in the time frame that's required for the ISO standard is becoming a challenge for a number of our customers. So making sure that our products scale to reach that need. And then we've got system scaling. Testing a device on a standalone is one thing, but as you can imagine, all these systems are vastly integrated now. So being able to test a full system is becoming more and more important, because the one little chip that you're making, if you test it on its own, that's great, but it is part of a bigger system, so we need to take that full system into account. So really, really pushing the bounds of the IC technology and our technology as well.
Yeah. It's exciting stuff.
I'm really excited with what's going on. I see a huge amount of technology advancement, and not just in the vehicles themselves, in the whole approach to transport. Talking to a professor just the other day, we were discussing whether to take a train or a plane to a particular destination. People don't want to make those choices anymore. They want an app on their phone that will make that decision for them. So bringing together kind of bikes, public transport, buses, trains, taxis, aeroplanes, putting point A to point B, and given the option of this is the most eco route to do it, this is the most economical route to do it, this is the fastest, and having that choice. So really bringing together all of the different parts of the transport network into one solution.
Lee, thank you so much for your time.